The graph shows the curve f of x is equal to the square root of x. What is the exact equation of the line PQ such that it bisects the area under the curve f between x is equal to 4 and x is equal to 9? If we just look at this GeoGebra applet, so here we have the graph of f of x is equal to square root of x. Okay, so the total area between 4 and 9 is 12.67, the green one here. Okay, we can move the slider, so what we want to do is move the slider such that these two areas are actually equal. So at the moment we can see one is 5.16 and the other is 7.51. We want to find the value here such that this area is exactly the same as this area. At the end of the video I'll come back to the applet and show you exactly where that is. But first of all we're going to do it using a little bit of integration. So going back to the problem, we'll call that A1 and we'll call that one A2. This is 4, we'll call this point here A and 9, and we want to find point A, or the equation of point A, such that A1 is equal to A2. So A1, so that will be the area between 4 and A of square root of x. So we need to integrate the function from 4 to A square root of x dx, and then for A2 we need to integrate between A and 9 square root of x, and we want to know where those are actually equal. So what we're doing is we're taking the problem and we're actually forming an equation here. Right, so we'll just use our rules of integration. So when we've got square root signs, we need to replace them with indices. So that would be from 4 to A of x to the half dx is equal to A to 9 of x to the half dx. Now when we integrate ax to the n, we add 1 to the power and divide by the new power plus c, provided n is not equal to 1. So in the first case, we're going to do x, we're going to add 1 to a half, we get 3 over 2, and then we need to divide by 3 over 2. Now, dividing by 3 over 2 is the same as multiplying by 2 over 3. If you're not sure about that fact, stop the video here, get a bit of paper out and sort of just check that. So just repeat what I said there. So if you need to divide by 3 over 2, then you need to multiply. That's the same as multiplying by 2 over 3. Between 4 and A, and then on the other side it will be the same integral, same result, 2/3 x 3 over 2 between A and 9. If we put in the limits, before putting in the limits, we'll write, this means take the square root of x and then cube it. So we're going to write the square root of x cubed, 2/3 of, and we'll do the same for the other side. Right, so then we'll write that out again, and now we'll put in the limits. So put in the limits, so we put in a first, so it's 2/3 the square root of a cubed minus 2/3 of the square root of 4 cubed must be equal to 2/3 the square root of 9 cubed minus 2/3 of the square root of a cubed. Right, we need to solve this equation for a. So that's 2/3 of root a cubed. Now the square root of 4 is 2, and 2 cubed is 8. So just repeat that. The square root of 4 is 2, and 2 cubed is 8. So it's minus 2/3 of 8 is equal to 2/3. Now the square root of 9 is 3, and 3 cubed is 27. That's 2/3 of 27 minus 2/3 of root a cubed. Now if you take that or add that to both sides, you're then going to end up with 4/3 of root a cubed. 2/3 plus 2/3 is 4 over 3. And on this side we're going to have a common factor of 2/3, and then that will be added, so that will be 27 plus 8. Again, if you're not sure, pause the video and have a good look, a long stare at it, and see if you can see if that's okay. Now 27 plus 8 is 35, so we're going to have, before we do that, the square root of a cubed, we need to, if we're multiplying by 4 over 3 here we need to multiply by 3 over 4, which means the 3's will cancel out and you'll end up with 2 over 4, which is the same as a half. I'll just repeat that. If you are going to do the inverse of multiplying by 4 over 3, you need to multiply by 3 over 4. Here The 3's will cancel out and you'll be left with 2 over 4, which is the same as a half. 27 plus 8 is 35. And now A will be 35 over 2. The opposite of taking the square root is to square, and the opposite of cubing is 2 over 3. So we end up with 35 over 2 squared, and this means take the cube root of it. So it's 35 over 2 to the power of 2/3. Now if you work that out on your calculator, you get approximately 6.74. So we wanted the equation of the line PQ. So the equation of the line will be x is equal to 35 over 2 to the power of 2 over 3, when we know that to be 6.74 in order to check the applet. So we go back to the applet, okay, and we move the slider so it says 7.4, and lo and behold we can see that the areas here, 6.33, 6.33 are equal. If we move them slightly either side, you'll see that they become unequal. Now they're unequal, and we move it back one, 6.74, we can see that this area here is equal to this area here. Now this applet I will put in the notes of the video so that you can try it for yourself. Okay, this has been a video to show you how to find algebraically how to put two equal areas and the equation of the line that bisects the area given the function. I hope you've understood, and I thank you very much for watching.